Honda's new diesel engine, the 2.2-litre i-CTDi, applies advanced intelligent combustion control, adjusting to engine speed and load to obtain optimum combustion under all driving conditions. The i-CTDi delivers outstanding performance in fuel economy, low emissions, output, torque, and quiet operation. The new engine combines a newly redesigned combustion chamber and variable intake swirl to ensure broad diffusion of the injected fuel. The optimized shape of the combustion chamber's cavities and lips helps disperse the fuel vertically, while the swirl created on the intake stroke promotes horizontal dispersion. Fuel is efficiently spread throughout the combustion chamber. Further, a ceramic glow plug and other innovations greatly improve low-temperature combustion stability, permitting the use of a low compression ratio of 16.7 to 1. Appropriate moderation of the combustion pressure reduces friction, vibration, and noise. Honda has also adapted a number of other leading-edge technologies to achieve advanced combustion control. The i-CTDi is fitted with a continuously variable swirl control valve at the intake manifold chamber to provide smoothly graded control over the swirl ratio. In situations where a high swirl is called for, a valve closes to limit the volume of air intake in the secondary port. This difference in the intake volume between the two ports generates a high swirl in the cylinder. Under conditions where a low swirl ratio is more appropriate, the valve opens wide, reducing the difference in intake volume between the two ports to lower the swirl ratio. The continuously variable swirl control valve thus ensures optimum matching of swirl ratio with engine speed and load, significantly contributing to fuel consistency. Another innovation that ensures lower intake resistance and aids in more efficient swirl generation is the tangential intake port. The common rail injection system stores the pressurized fuel in a single common rail as it awaits injection into each individual cylinder. Fuel injection pressure and timing can be regulated for optimum performance in response to changing driving conditions. And a small amount of fuel injected prior to the main injection, called the pilot injection, helps lower combustion noise. For the new engine, Honda employed a second-generation common rail that attains a maximum injection pressure of 1600 bar. A variable nozzle turbocharger ensures optimum control over intake pressure, facilitating higher intake pressures, greater fuel economy, and fewer harmful emissions. A high-flow electronic EGR valve and water-cooled EGR cooler lower the temperature of recirculated exhaust gases, increasing intake air volume and reducing nitrogen oxides and particulates. The new i-CTDi engine makes use of these leading-edge variable control technologies to achieve a major increase in combustion control flexibility. The various controls are freely combined to attain optimum combustion regulation throughout the engine's entire range. Now let's take a look at some examples of combustion control. In city driving, where mid-RPM, mid-load conditions are prevalent, combustion is regulated to attain the optimum balance of fuel economy, low emissions, and quiet operation. A pilot injection creates conditions conducive to ignition inside the combustion chamber. This helps the main injection of fuel ignite more smoothly and prevents sudden explosive combustion, reducing combustion noise. Meanwhile, optimized swirl control ensures consistent diffusion of the fuel, promoting enhanced fuel economy and lower particulate emissions. Exhaust gas recirculation is also increased to reduce nitrogen oxide levels. The new engine reduces combustion noise while improving fuel economy and reducing toxic substances in the emissions through fuel control. During idling, the emphasis is on controlling combustion noise. Injection pressure is lower and exhaust gas recirculation higher than during city driving. This results in smoother combustion and less noise. A high swirl reduces carbon monoxide and unburned hydrocarbons. During times of high engine load, such as passing and high-speed driving, fuel injection is increased to the maximum pressure of 1,600 bar. The swirl control valve is also fully opened to ensure maximum air intake, generating high power and torque. These are just a few examples of how the i-CTDi's various controls function together, continuously providing the optimum response to constantly varying driving conditions so as to achieve the best possible balance of fuel economy, low emissions, power, torque, and quiet operation. Fuel economy is further enhanced through the use of offset cylinders, roller follower rocker arms, and other innovations. A closed-coupled oxidation catalytic converter and an underfloor denox catalytic converter have been added to further reduce exhaust emissions. Reduction of vibration and noise have been enhanced through the use of a high-rigidity aluminium lower block, a balance shaft, and an acoustic engine cover. The engine mounting system employs a pendulum design to effectively absorb the low-speed torque fluctuations peculiar to diesel engines. The angle of the torque rod has also been optimized and the mount joints made more rigid to achieve the quietest possible operation. Thanks to these new technologies, the i-CTDi-equipped Accord diesel attains fuel economy of just 5.4 liters per 100 kilometers, along with environment-friendly performance that already meets Euro 4 exhaust emission standards for 2005. The Accord diesel also delivers outstanding performance. Its 103 kilowatts of power and 340 Newton-meters of torque place it at the top of its class, with no sacrifice in quietness. In developing the i-CTDi, Honda turned its focus to improving production technologies. Honda's original semi-solid casting technology has resulted in the world's first semi-solid mold with a sand core, which makes it possible to manufacture an aluminium cylinder block that is strong and rigid, as well as compact and lightweight. To ensure the new engine's high rigidity, we employed a closed-deck suspended configuration for the coolant passages in the cylinder block. To create the suspended configuration, we applied casting technology that utilizes a sand core placed inside the outer mold that is dismantled and extracted after the molding process is complete. In regular high-pressure casting, it's difficult to use a sand core as the molten aluminium is rapidly injected into the mold at high pressure. In this production process, the aluminium is injected in a semi-solid state so that it flows relatively slowly. The semi-solid aluminium is in a state halfway between liquid and solid. It is so soft it can be scooped up with a spoon, allowing for more precise casting than is possible with conventional methods. Other newly developed technologies essential for the production of highly rigid closed-deck construction include a high-pressure resistant coating for the sand core and the use of a high-pressure water jet for its removal. This process also enables the use of post-casting heat treatment, a procedure that is difficult when high-pressure molding is used and which results in a harder cylinder block. Keeping the thickness of the aluminium between the bores to a mere 3 millimeters made it possible to achieve an engine length on par with that of a gasoline engine. This process results in a high-strength, high-rigidity aluminium cylinder block that is also compact and lightweight. We also incorporated an isolated drive pulley, an oil filter module and an auxiliary module, as well as other features to make the new engine even more compact and lightweight. In developing this new diesel, Honda pushed technological innovation to the limit at all stages, from design to control systems to production. The result? The new Honda 2.2-litre i-CTDi, the state-of-the-art diesel engine that delivers outstanding performance in fuel economy, low emissions, output, torque, and quiet operation.